In laboratories across the country, doctoral students are conducting the high-stakes research that drives engineering, computer science, and the physical sciences. Yet for the majority of these researchers, the finish line isn't a university classroom. Over 65% of PhD graduates in these fields, with confirmed employment, are moving directly into industry. This creates a specific tension. While these graduates overwhelmingly enter the corporate sector, their training remains almost exclusively designed around an academic career path. Historically, the doctoral model, represented by these traditional regalia, was a closed loop, built to produce the next generation of university faculty. We are manufacturing advanced research talent for an innovation ecosystem that no longer matches the original academic blueprint. This educational architecture functions as a rigid one-way pipeline. In this linear model, the university trains the researcher, the student earns the PhD, and the talent is eventually handed off to industry. The inefficiency lies in the isolation. Universities often develop talent without direct input from the commercial environments where research is applied. For decades, companies have accepted a passive role in this system, simply waiting at the end of the pipeline to consume whatever talent emerges. As the speed of innovation accelerates, we have to ask if this linear structure is still effective. Is PhD training keeping up? One answer comes from the National Science Foundation. The NSF recently announced a $47 million pilot program involving more than 250 doctoral students, testing a new 4-year PhD model. Beyond the budget and the timeline, the program's significance lies in its structural redesign. In this model, students conduct dissertation research directly inside corporate R&D settings, integrating real-world industry problems into their graduate education. This shifts the focus from pure academic theory to a model where research, education, and real-world application happen within the same system. This pilot begins to dissolve the old linear handoff. The educational pipeline is becoming a continuous feedback loop, where the university, the researcher, and the corporation are constantly linked. The traditional dynamic changes. Instead of a single advisor, students receive simultaneous guidance from both academic and industry mentors. Industry is stepping away from the role of a passive recruiter who simply hires finished products. We are seeing a shift in identity. Industry is moving from being a consumer of PhD talent to becoming a co-developer of that talent. If this model scales beyond a pilot, it will redefine how we view the value of a research degree. The historical model of breakthrough research often focused on the solitary investigator working in an isolated laboratory. In the future, the competitive advantage of a research university may increasingly depend on how effectively it connects its faculty and students to external innovation networks. The goal is to integrate these 4 variables, research, talent, industry, and real-world problems, into a single functioning unit. When these elements work together, they form a self-sustaining innovation ecosystem. The NSF pilot is one signal of a broader system shift. It leads to a larger question for the future of higher education. What happens when the boundaries between learning, research, and work begin to disappear? BE Global Insights. One signal, one insight, why it matters.